Welcome everyone to this webinar session on using open source software to support data analytics. I do hope you find it a useful and informative session. My name is Robin Clough and I'm the Managing Director of DataConsulting. Today I'm here just to introduce the session and wrap things up at the end. My esteemed colleagues, Tom and Levi, have developed the material and so will be presenting the bulk of the session. Hopefully the first of a few sessions that we're going to run. We thought open source software would be a great topic to kick off with. In recent projects, we found it a useful avenue for overcoming some of the more challenging aspects of performing data analytics. It's also accessible to all regardless of the size of your budget. Let me just knock it onto the next slide, please. Before I hand over to Tom and Levi, I'll just give a quick overview of our company, DataConsulting. We've been around for over 13 years now, and our focus has always been to help organisations get more from their data. And in particular, those departments such as internal audit or finance, where readily available data analytics skills or tools might not be accessible. We work across a breadth of data analytics tools ranging from Excel through to Python with plenty in between. During the session, please feel free to put questions into the Q&A box and we'll try and cover off the questions either during the session or afterwards by email. Well, that's enough for me for now. Over to you, Tom and Levi.
Thanks, Robin. So the talk will be in two parts. The first will be a basic introduction to open source tools. So hopefully you'll be able to get a good idea of a few of the tools and what you can do with them, some pros and cons, and a couple of examples of where we've used them in our work at DC. After that, we'll move on to a case study. So this case study is very closely modelled on a real project that me and Levi have done for one of our clients recently. Levi's actually still involved in some of the follow-up to that. So we'll go through how we've used open source tools at each stage of the project, from data gathering, data prep, the actual analysis that was involved, as well as visualization and reporting as well. First up, what is open source? So the basic definition, as you can see here, is software for which the original source code is made freely available and may be redistributed and modified. We'll touch on what that really means in practice over the next few slides. So some examples of some open source tools. So first up we have Python. So this tends to be the tool that me and Levi use most frequently. Essentially it's a jack of all trades when it comes to DA tools. It's used widely for a number of different applications, things like data cleansing, visualization, data science, all the way through to non-DA tasks like web development, scientific modeling and games development. Next we've got R. So this tends to be used more for statistical analysis. Used a lot in research and in academia. Next up, we've got D3. So D3 is a visualization library written in JavaScript. This means you can build dashboards and custom visuals, which you can use directly from the browser. So you don't need any specialist software like Tableau or Power BI. We've also got a few more. So we've got Weka, which is a machine learning tool, and MySQL as well, which a few of you may have used. So the focus on this talk will mostly be on Python. As I said, it's one that we've got most experience with, and it really does cover a very, very wide range of tasks. The case study we'll show at the end as well, we'll use Python as well as some visualizations in D3 and Leaflet. So I'll hand over now to Levi, who's going to talk a little bit about some of the benefits and some of the drawbacks of open source.
Yeah, thanks, Tom. I think probably the biggest benefit when it comes to using open source tools is that it kind of allows community contributions to be added to sort of the base tool. And this basically just means that anybody can write their own kind of add-on to the base tool and publish that, and it can be used by kind of any other user. And so Python has over 240,000 of these add-ons, which are called modules in Python. And I think sort of Tom touched a little bit on this, but these kinds of add-ons can vary quite significantly in nature. From things such as large data science frameworks, web frameworks, visualization tools, as well as sort of smaller kind of utility type tools. So things like advanced maths functions, CSV readers and writers and various other file types, and all sorts of different things. I think some of the main ones include, at least for us, pandas. Pandas is kind of the one we use most often, I would say. And this is Python's data manipulation and analysis tool. So this loads a data file into what's called a data frame. And this is kind of like the equivalent of an ACL table or like an Excel worksheet. So here you can sort of assess your data for quality and validity, and also for any sort of manipulations or analysis that you want. NumPy is, for us at least, normally used as kind of an advanced maths library. So any sort of functions that we need that are not in the sort of standard Python math library, we can access through NumPy. Also does various other sort of statistical functions. TensorFlow is a machine learning framework. So this is made by Google, but used through Python. I think Tom touched on Weka. This is just sort of another kind of tool which you could use to perform machine learning. And again, finally, I'll just mention Matplotlib. Matplotlib is sort of the original visualization library that was used in Python. So this was made by the same guy that wrote MATLAB. He's kind of tired of the sort of rudimentary visuals that you could do in Python, and so wrote his own module to be able to do sort of what he wanted. Again, just mentioning this sort of community aspect I talked about at the start. I think as well as being able to sort of add any module onto the base tool, just the fact that you do have quite a large sort of community around each tool means that there's always some help and examples out there. Normally, if you're sort of searching online for a problem that you're trying to solve or some method that you want to try, someone's been out there and either done something that's the same or similar that you can sort of learn from, maybe even sort of extract some of the code and adapt it for your own needs. I think worth mentioning as well, open source software is free to use. The only real exceptions to this are certain companies who write these add-ons. Sometimes will offer kind of premium versions. This normally just means that you'll receive either extra support from that company or have some sort of influence over sort of future additions to their particular add-on. As well, we'll touch a little bit more on this later on. It's quite easy to integrate, certainly Python, with tools such as Tableau, Power BI, and ACL or Galvanize. Normally there's either a plugin in the sort of package itself or a Python module which will allow you to sort of feed it in and just perform more advanced manipulations than you might be able to do in the native tool. So I think just briefly mention some of the drawbacks as well. I think the biggest drawback is probably the learning curve, which can be quite steep. Obviously, this does depend on which tool you're using. So with Python, for example, it's actually quite easy to sort of jump in and start coding and start actually producing some analysis or visualization or whatever you want to do. Something like D3, which again we'll show you a little bit later on. This takes quite a bit longer to learn. I think the sort of benefit of making that trade-off though is that you really do get to sort of customize your visuals completely and manipulate them sort of however you'd like. Also worth mentioning as well, less out-of-the-box functionality you'll see written there. This basically just means that it's a little bit harder to get where you want to go. In that if you're working in something like Power BI or Tableau, you tend to just sort of drag a visual onto the page and have it populated with your data set. Using something like Python, one of the visual tools in there, you'll always require at least a few lines of code to get your sort of visual up and going. And finally, just to touch on the business side, I think it can be a little bit harder to get business approval to use these tools. And I only really want to make that point just to say that, these tools are not always kind of the big recognizable brand names that you might associate with your standard tools, your Excels, your Power BIs, Tableaus, etc. And if your management's not familiar with those tools, they might be a little bit skeptical to get on board. So I think we'll move on now a little bit and start to talk about some of the things that you can actually do with these open source tools. And I'll hand you back to Tom to get us kicked off.
So the first one on this list is data prep. So loading data into Python tends to be the first thing we'll do whenever we're starting a new data analytics project. So Levi mentioned pandas, so it's really helpful. It's a really good way of inspecting the data, finding out where you might have issues. And then with all the additional libraries you can bring in, you can really fix all those issues in a single place. I think Leo's going to touch it a little bit more in the next slide, but you can really connect to almost any different file type. So from simple files like CSVs or Excel files, PDFs, things like that, all the way through to Parquet files and various different database and cloud structures. So on to the next one. I think normally when people mention tools like Python, the first thing that they talk about is machine learning and data science, the more advanced kind of projects. But actually, you can just as easily do what I guess you call standard sort of audit analytics, things like duplicates, finding irregular payments, and round sums, and things like that. And as we mentioned earlier as well, you can also integrate Python and R with tools like Power BI and Tableau. So one place that we've used this is in finding fuzzy duplicates. We did this in the name field in payroll data, and then it was integrated directly within a Power BI dashboard. So the reason we did this is that the Power BI fuzzy duplicates command wasn't fully customizable in the way that we needed for the data that we had. So one of the key advantages of using this kind of approach is the customization that you're afforded. You can really build the algorithm to do whatever you want. So you can write one from scratch, or you can borrow from other people's code. Of course, there's also, you can do machine learning and data science. In fact, Python does tend to be the go-to for that kind of thing. So things like regression models, which you might use for some kind of business modeling problem, modeling cash flow, things like that. The clustering algorithms, which we've not put here, but you might be able to use those to spot fraudulent transactions or outliers in data sets. We've also got NLP analysis. So this stands for natural language processing, which you might guess refers to text-based analytics. So this allows you to analyze more unstructured data, things like emails, news articles, tweets, maybe things like that. So one place that we've used NLP analysis is for one of our clients. We help them measure the sentiment behind open response questions within surveys of their employees. So it really helped them gain an insight into how different demographics responded compared to the general workforce in ways that you probably couldn't do with standard analytics.
So with the sort of data collection point here, I think Tom sort of touched quite a lot on the data prep in the previous slide, and I just wanted to mention again, sort of drawing comparisons to tools that you might be familiar with. That most packages that you use will have quite a wide range of different file formats which you can sort of read and parse and draw into your software of choice. The open source tools are not really any different here. If there's a sort of file format that you can think of or that you want to use, there will normally be a tool pre-written which will allow you to read that into, for example, a pandas data frame and work with it. I think that's sort of one addition I wanted to make to the sort of data prep that Tom mentioned was this idea of web scraping, or actually sort of collecting data which you maybe didn't have originally. So what web scraping is, we'll touch on a little bit more later, is basically just extracting information from a web page or a series of web pages, and you can use this to either generate a sort of an initial data set or even to enhance an existing data set. As for visualization, mentioned matplotlib at the start, although that does tend to be used for sort of more static visualizations. It's quite popular with sort of publications, just to visualize general data. Other libraries in Python include Seaborn and Plotly. These are geared more towards kind of interactive visualizations and dashboard type applications. And again, Leaflet and D3, which Tom mentioned at the start, and we'll show you later on. These are JavaScript libraries and allow you sort of more complete customization and manipulation of the visuals that you want to make. There are sort of more kind of packaged up visual tools as well. So an example of that is Kepler, and this is kind of built on top of Leaflet that I mentioned, but it's kind of almost a finished product and will allow you to kind of just plug in the data that you want to use and create these quite nice looking visuals. Just touching on automation as well. So I think when I sort of talk about automation in this sense, I'm really talking about kind of this idea of automatic reporting, or sort of sending emails automatically, schedule analytics, and also things like sort of live visuals, which you can get going with these tools. So I think a nice example of this kind of whole process of these 3 points is a bit of a side project that Tom and I have been working on in the last few months. That just involves scraping Premier League football data from a certain website, cleaning and formatting it, and then feeding that into a dashboard in D3, which then updates each time we sort of run the scraper. And I think that's really just this sort of testament to the versatility of these tools, that they integrate so seamlessly, and you can kind of just take the best bits from each and use them sort of for whatever purpose you wish. So hopefully that's not too much information for the sort of first half of this talk. I think at this point we would take some questions if we were still doing this live, but instead we'll just move straight on to a little case study. So I'll hand you back over to Tom to introduce it.
Levi. Yeah, so on to the case study. So as I mentioned before, it's based closely on a real project that we've worked on. Just to give you a bit of background onto the project. So one of our clients is a manufacturing company, and they've got a commitment not to sell their product within a certain radius of hospitals in Romania. So the initial data that we've got is a publicly available list of hospitals. That's just from the Public Health Romania website. We've also got a client's point of sales data, which includes an address field. So essentially, the task is to obtain accurate latitude and longitude coordinates for both the hospitals and the points of sales themselves, and then to find violations. So this is cases where a point of sale is within a certain distance of a hospital. Once we've got the results, we want to report on them with kind of visual aid, some kind of dashboard maybe, to help the auditors understand what's going on. So for this case study, we've set the limit at 2.5 kilometers. We've also used dummy point of sale data just to keep everything nicely anonymous. So you may notice that some of the business names are fairly un-Romanian. So just to expand on the previous slide, you can see at the bottom here, this is essentially the process that we're going to go through for this project. So we'll start with the 2 raw files, hospitals and points of sale. And we'll do all the necessary data prep work that we need to do on them. And then once we're happy with those files, we go into what we call the data enrichment stage. So this is the point at which the web scraping happens. So we'll be able to get all the latitude and longitude information, addresses, and any other kind of additional information that might be helpful for this analysis. Then we'll do some validation. So once we're happy that the validation's done, we're happy with the results, and we're confident in the accuracy, then we'll move on to the analysis section. So this is stage where we actually perform the analysis. So in this case, that means calculating the distance between each point of sale and each hospital, and flagging those cases where a violation has occurred. Once we've got the results from that, we'll do 2 further things. So the first is reporting. So we want to automatically generate a report and send that to the relevant person. So that might be to an auditor or to the approvers. And then we also want to populate a dashboard, as I mentioned before.
So you might have noticed on the previous slide that the sort of initial input for this project involved 2 files. So these were a file for points of sale information and also for hospital names. So we can't show you the points of sale file in this presentation, but we will show you the hospital file in a second, just to sort of give you an idea of what we're working with. But I think we just sort of wanted to mention in a bit more detail the data prep, just to kind of try and draw some comparisons with maybe some tools that you might be used to. And so initially, when looking at the points of sale file, we noticed that we had a field with an address in, and also information about city and county location, and that sort of thing. So the first problem that we had was that in this address field, sometimes it already had this city or county information, sometimes it didn't. And so we just have to sort of write a little bit of logic for that to check whether it is in there, and if not, then we can append it. As well, we had sort of Romanian specific characters. You can see sort of a couple of examples on the screen here. And that was a little bit of a problem when using the search API. It didn't take too kindly to them. So again, we can just import a module which will decode these into sort of a standard English format. with just 1 or 2 lines of code and output sort of a kind of API search string that we need. So I think if we just have a quick look at the hospitals file, you can probably see a little bit about what I mean. So here is the list of hospitals that we've got. I think, it's not an ideal scenario. We've just got sort of names of hospitals, no actual location information, where we want to get kind of coordinate information for where these places are. I think fortunately for us, most of these places got quite Romanian specific names, quite unique names, and so for the location that we need to go. There are some cases which are a bit more sort of English or generic sounding. You can see here like laser system, SRL, and you definitely can't guarantee that they're going to take you to the right place or even to Romania. And you just got to sort of think about these things and try to account for them when you're running your searches. So just move on to the next slide. I'll just briefly mention before we sort of go into showing the web scraper in action. I mentioned earlier that web scraping is basically just a process for extracting data from websites. And in this case study, we're using Selenium and Beautiful Soup. So these are both Python libraries. Selenium is a kind of automated web browser, and Beautiful Soup is a HTML parser. So we just dive into the video and we'll sort of try to explain what's going on a little bit. And you can see at the top here it says Chrome is being controlled by automated test software. This basically just means that this kind of Google Chrome browser is being controlled by Selenium in Python. And so everything that's searched for and everything that's clicked on, etc., is all sort of pre-programmed into the Python script, and we're not actually sort of doing anything here. So I'll just hand you back to Tom now to take you through kind of the basics of what's actually going on here.
Cheers, Levi. I think just one further thing to point out, just before we start, so that this is probably a fairly advanced use of web scraping. Normally, you just sort of use scraping data from tabular websites, which is a lot more static, it's a lot more straightforward, and you've probably got fewer complexities to think about. So let's get started. Okay, so you can see here, we've made the initial search. So this is the start of the scraping process. As you can see here, we've entered the URL that Levi mentioned a few slides ago. You can see in this case we've returned 3 possible results. As you can see, one is in Bucharest and 2 up here in Moldova. So essentially what we want the algorithms to do is we want it to decide which is the best option. Click on that option in this list and then find the information for that place. So we have a set of logic in the script that essentially helps the Google Maps to decide which is the best option and then click on it. A lot of the time it does tend to be the top option just because Google Maps' logic is pretty good itself. You can see we make that decision, we decide that this is the best option, and then we get the browser to automatically click on that point. So you can see here we've got a little bit of information about the hospital. We've got the name, we've got address, we've got some website, phone number information, which we're not particularly interested in. But you can also see up here we've got latitude and longitude. So the way that Google Maps works is that this latitude and longitude refers to the center of the screen, so it'll be somewhere around here. So we're not particularly interested in that point. So what we want the browser to do is we want it to recenter on this hospital point. So we do that just by entering a slightly modified URL. I won't bore you with the details of that. But as you can see here, we end up recentered on this point. So you may notice that we're centered on this point, but we're centered within what we call this viewport here. We're not centered on the screen itself. So that is a problem, as this latitude and longitude refers to the screen itself. So we'd end up getting latitude and longitude for a point around here. So one workaround that we found is getting the browser to locate this zoom button in the page and click on that until we get to the point where we're as zoomed in as we can be. And then once we're there, as you can see here, we'll take the latitude and longitude. It might be a couple of meters away, but it does tend to be on the building itself. We'll take the latitude and longitude, we'll take the name, we'll take the address details, and we'll move on to the next hospital.
what Tom mentioned there, using this kind of zoom button as a little workaround. You know, I think with this sort of web scraping, you do really need to kind of understand the web page that you're working with. So, for example, here, the sort of, I guess you could say, a proper way to do it might be to sort of look at exactly where that marker is, and get those coordinates. And to do that, you could right-click on the marker, create another point, and then there's an option called "What's Here," which will produce a sort of a little pop-up on the map and give you coordinate information. So that's quite a few extra clicks. You then have to locate that pop-up and extract the information from that. And that's maybe like 8 to 10 seconds per sort of search that you might add, maybe a little bit longer. If you're doing quite a few thousand searches, it really does add up quite fast to a significant amount of extra time. For what's kind of marginal, if any, gains in accuracy. So with this sort of zoom method, we're always still well within the premises, just not quite on the sort of marker that Google assign. And I think as well, when we're sort of running these searches, we sort of encountered several different scenarios, and so as we just play through, you'll see a few of those, and you really do sort of have to kind of account for all of these different scenarios. And in this case, we sort of felt it quite important to mark what was happening when each scenario occurred. So here you can see we've sort of not returned any result. We ended up back in Tom's hometown as Keithley as the default location. And so here, we've got to tell the scraper, first of all, don't crash, carry on running. It's definitely, don't extract any information. Just, put a note into the output file and move on to the next search. And so as we just sort of play this video through, I think you'll see some more kind of scenarios. This is kind of the ideal scenario now, where we've made a search and immediately we've snapped to the place that we want. So you notice here as well that the marker that you see on the screen is actually in the center of the screen rather than the center of the viewport, which means, if you're listening to Tom earlier, the coordinates that we get in the URL can be immediately sort of extracted along with the address information in the name. And this kind of scenario accounts for about 80% of the results that we get, which is quite nice. And sort of most of the other logic that we've shown to work around is kind of trying to account for those other 20% of results.
Cheers, Levi. Yeah, so I'll just touch on the validation before we move on. So we do two stages of validation. The first one is a sort of automatic validation process that we call reverse geocoding. So what that means is we take the latitude and longitude points that we obtain and we run them through the OpenStreetMaps data. So this is Google Maps. We also use OpenStreetMaps, which means we're essentially using two different data sources. And if we find that we get the same place using both sources, then we can be fairly confident that we've got a decent match. It also allows you, like Levi said earlier, you could get cases where it returns something in completely the wrong country. It really allows you to quickly identify those issues. So the second stage of validation we do is just old-fashioned manual sampling. So in this project we worked with auditors to manually sample, I think it was 30 or maybe 60 of the results, just to get an idea of how accurate they were, how accurate each different, what we call statuses, which you'll see in the next slide. So those automatic matches or the multiple match cases. And that really lets you understand how accurate your data set is going to be. So you can see here, this is the information that we're able to acquire. So on the starting point of just this hospital name, it's quite comprehensive. So we've got a latitude and a longitude. We've also got a name and subname, which we sort of use mainly for just spot checks, just to make sure they do tend to match up. We've also got the address that we've scraped and the status description, like I mentioned before. So you can also see the cases where we've not got an address, we've not taken any of this information, so we've not captured Keithley or any other weird things that we don't want. And we've also just put no address found, no match found. We've really just tried to make it as clear as possible how we've obtained each match. So once we've done that, we've done all the analysis, we've done all the validation, we're happy with the results. Move on to the analysis stage. So we're using pandas that Levi talked about quite a bit earlier. We're also using Python's built-in math library for the analysis. This is for things like sine and cosine that you need to use when you're calculating distances and taking into account the curvature of the Earth. So we want to bring the data sets together, compare each point of sale location with each hospital location, and then we're going to calculate a distance between each possible pair. So yeah, as you can probably imagine, this can be quite intensive. So I think there's around 4,000 hospitals and around 10,000 points of sale, which you can probably imagine is around 4 million comparisons. I think in the actual project it was around tenfold of that, but Python deals with that without any trouble. So once we've done all that analysis, results under a certain distance are filtered and marked as violations.
And I think, again, just wanted to touch on the reporting side. So I mentioned the automation part earlier on. In this case of this little project, all we really wanted to do is generate a report of all of the violations that we found, sort of under the distance we specified, and have this emailed to the relevant person automatically. We really wanted to mention this just so we can sort of show you how that's done. So just bring up the sort of code snippet onto the screen. I think, for those of you that aren't sort of into coding, it might kind of look a little bit overwhelming to see this, 55 lines of code. But really, the sort of idea is that we want to get across that we decided that we wanted to do this kind of automatic email thing, and we thought, let's look and see what's being done. Is there any sort of inspiration we can draw from? And we're able to lift most of this code directly from the documentation, just changing the kind of email details and adding this little function to be able to attach a file. Yeah, again, if you've got a sort of a problem or an idea, it's always worth just looking around. There's almost always someone that's got something similar that's ready to go and just needs adapting a little bit for your own purposes. So again, this is kind of just an example of the report that was sent for this project. This is just the basic sort of Excel output that you get from pandas. You can sort of format this however you like. It can be sort of as simple or as complex as you like. But yeah, it really does just depend on the needs of your sort of specific purposes. So I think we'll sort of jump into the visualizations now. I'll just sort of hand you back to Tom to introduce it.
Cheers, Levi. Yeah, so as we mentioned before, I think most of this slide is things we've mentioned before, but we're using D3 and Leaflet for this dashboard. So they're both JavaScript libraries, which means that they're fully JavaScript, HTML, and CSS based. And just to remind you what we said earlier, that essentially just means you can use them with just modern web browsers. No specialist sort of viewer software required. You can Google Chrome, Internet Explorer maybe, might be a bit old for it, but yeah. So in this case, the data files are stored on GitHub, but could just easily be stored on a company's network drive or cloud system. I know a few people have some sort of security concerns when you hear open source, but you can really just store your files in the secure way that you're used to, and just reference them from a file path. So I think next Levi's going to touch a bit on the process that we go through, or that we went through when developing the visualization. We've got a nice diagram for you as well.
Yeah, I think we weren't really sure whether to actually show off our kind of advanced paint skills. Just wanted to give you an idea of the sort of thought process behind producing the visuals that we wanted to get. But we sort of had this idea where we'd plot points of sale and hospitals, and also plot the kind of distance between them, which is kind of what you can see here. But it was also important for us to just be able to sort of move between different violations quite quickly. So to sort of be able to zoom in and out and pan to a different location kind of as we click. And leaflet, which we'll go to in a second, I think that was the one that really just allowed us to quite quickly implement this sort of solution. And it really sort of became quite useful in analysing the violations visually. So we'll just click through to it now. So again, this is written in JavaScript, so it's just hosted in your browser. However, you don't need, you don't need to host on a website. You can computer drive. You can see we've just sort of thrown a few basic visuals together on the right-hand side. These are written in D3, just to give you a sort of idea of some of the things that you can do with these libraries. You can do much more advanced things as well. We just chose not to show them here. So the main feature of this is really the map, again written in Leaflet. And I think Tom will sort of click through on some of these now. And you see, when you click on one of these markers, what's happening kind of behind the scenes is that's calling a function, which resets the sort of center point of the camera to that location, and also resets the zoom so that you can see a sort of street level view. And you sort of see why we wanted to make this visualization rather than just generate a report. So here you can see, the distances might be violations, but the actual route to get to that hospital from the POS, probably a little bit more convoluted, and probably, possibly not quite an exception in the way that we might have thought initially. So again, Tom's just clicked this sort of reverse button. That's something that we added to Leaflet. So the base sort of Leaflet map just comes with these kind of plus minus zoom signs. So again, we're able to just add this button and call a function when we click that button. That function doesn't have to be a zoom or a pan. It could be whatever you like. If you want to flip the map around or change its size, imagine you can write a function to be able to do that too using those buttons. So yeah, I think Tom's just sort of sorted this table on the right hand side here, and you can see that this ProStar guide management at the top is in sort of violating range of 21 hospitals. Obviously, this is fake data, so ProStar guide and management are not in any real trouble anytime soon. But again, just sort of shows you, I guess, puts a little bit more emphasis on the problem. And gives you an idea of where sort of the real problem areas are. You can sort of knock out 21 of those violations in one go by just moving or removing. So I think that about covers it for the visualization and for the talk. I think again we'll try to get back to you with any questions that you had in the talk afterwards. And for now, I'll hand you back to Robin.
Brilliant. Thanks, Tom and Levi, for a great session. Certainly lots to think about, and I'm sure it will have whetted everyone's appetite for dipping into open source software. This particular slide shows our standard approach we use for our data analytics projects, a tried and tested approach. I certainly expected open source software to be useful in the early and middle phases of the approach, but was personally quite surprised at the powerful visuals that can be created using open source software too. The opportunities with open source software seem to be limitless. Certainly opened my eyes a little over the last few months as to what can be achieved. You want to just put it on to the next slide, please, Tom? We have actually recorded this session, and a future date will forward on the link to you all in case you want to watch it again, or possibly you might want to share it with colleagues or associates. On this particular slide are our contact details. Please do feel free to get in touch if you want to chat about anything in and around data analytics, and possibly any assistance you may need. We're a friendly bunch, and always happy to hear from you lot. This is our first session that we've done, but the plan is to do more. So we'll certainly be in touch about any sort of future events. I do hope you've enjoyed the session, and it just leaves me to say I hope you all have a pleasant weekend and enjoy the rest of summer.